Okay, let's start. Uh, Knowing basic cardiac principles and understanding the autonomic nervous system ensures mastery these five general areas of routine EKG interpretation, that is, rate, rhythm, axis, hypertrophy, and interaction. Rate. The SA note, SA note, the heart pacemaker, the dominant center of automaticity, generates a sinus rhythm. The AC note paces the heart in the normal rate range of 60 to 100 per minute. 60 to 100 per minute. If the sinus node paces the heart rate slower than 60 per minute, this is sinus bradycardia. Sinus rhythm rate less than 60 per minute. Sinus tachycardia. If the sinus node SA node SA node paces the heart at a rate greater than 100 per minute, this is sinus tachycardia. Sinus rhythm rate more than 100 per minute. Note, there are focal areas of automaticity in the heart known as automatic foci. These are automaticity foci. Automaticity foci. These are potential pacemakers. They are potential pacemakers that are capable of pacing in emergency situations. Under normal circumstances, these foci are electrically silent. That's why they are referred to as potential pacemaker. Potential pacemaker. If normal SNO pacemaking fails, other potential pacemaker known as automaticity foci, also called ectopic foci, have the ability to pace at their inherent rate. They are in the atria, ventricles, and the AV junction. The atria have automaticity foci of potential pacemakers. They are within the atrial conduction system, and they are called atrial automaticity foci. Atrial automaticity foci. The proximal end of the AV node has no. There is proximal end of the AV node has no automaticity foci. However, the middle and distal region of the AV node, an area known as the AV junction, does have automaticity foci that are called junctional automaticity foci. Have junctional automaticity foci, atrial automaticity foci, automaticity foci level, atrial level, AV junctional level, and ventricles level. The automaticity foci of this level, the atria, the AV junction, the ventricles are is a level, have a general range of pacemaking rates. Although all foci of given level pace within general rate range, each individual's automaticity focus has its own precise inherent rate at which it passes. That is atria 60 to 80 per minute, AV junction 40 to 60 per minute, ventricles 20 to 40 per minute. Pacing rates of automaticity foci: atria 80 to 60, junctional or 60 to 40, ventricular 40 to 20. A cardiac cycle is represented by the pure, the Q are trace complex, and the dual. The baseline that follows the baseline that follows until another pure appears. The baseline that follows until another pure appears. This cycle is repeated continuously. Please study the illustration to make certain that you understand every event in sequence. Please read it. Physiologically, a cardiac cycle represents atrial systole, atrial contraction, followed by ventricular systole, ventricular contraction, and the resting stage that follows until another cycle begins. SA node overdrive suppresses all foci. Since all foci have a slower inherent pacing rate, SA node overdrive suppression, atrial foci, junctional foci, ventricular foci. Rapid automaticity, pacemaking activity suppress slower automaticity, pacemaking activity. This is overdrive suppression, a very important fundamental characteristics of all automaticity centers. Overdrive suppression provides emergency backup pacing at three separate levels. Emergency fail-safe pacing mechanism. This is called emergency fail-safe pacing mechanism. Overdrive suppression is the heart's fail-safe pacing mechanism, providing three separate levels of backup pacing by utilizing automaticity foci in the atria, the ventricles, and the AV junction. SA node. If failure, then atrial focus assumes pacing responsibility. If atrial focus failure occurs, then junctional focus assumes pacing responsibility. Then if failure of junctional focus, then ventricular focus assumes pacing responsibility. Atrial automaticity focus, potential pacemaker. Inherent rate 60 to 80 per minute. The atria have automaticity foci of potential pacemakers. Any one of these can assume active pacemaking responsibility in its inherent rate range of about 60 to 80 per minute if normal pacemaking fails. If normal pacemaking fails, then atrial automaticity focus take the responsibility. AV junctional automaticity focus, potential pacemaker, proximal of AV node, have no foci. AV node, inherent rate 40 to 60. The AV junction has automaticity foci, one of which will emerge to actively pace its inherent rate range of 40 to 60 per minute if there is an absence of regular pacing stimuli progressing down from the atria. AV junctional automaticity focus, potential pacemaker, that is inherent rate 40 to 60 per minute. Complete conduction block. If there is a complete conduction block in the AV node above the AV junction, then no regular paced deposition stimuli from above reach the automaticity foci in the AV junction. Ventricular automaticity focus, potential pacemaker. The ventricles have automaticity foci, potential pacemakers, any of which will assume pacing in its inherent rate range of 20 to 40 per minute if the usual overdrive suppression is absent due to regular pacing stimuli from above. Ventricular automaticity foci are composed of specialized Purkinje fibers. These pacemaking foci are in his bundle, the bundle branches, all their subdivision since they are all composed of Purkinje fibers. The ventricular focus emerges as the active ventricular pacemaker only if it is no longer override suppressed by regular rest stimuli above. This occurs if all pacemaking centers above it have failed or if there is complete block of conduction below the AV node, including the AV junction, that prevents any pacing stimulus above it, that is, from the AC node and atrial focus or junctional focus from reaching the ventricles. Read again. Okay. Now we are counting heart rate. Next, this is a PQRST complex count of 300, 150, 100 for 3 lines that follows the start line. Naming this line as shown. Memorize these numbers. First of all, again, for counting 100, we have to find R wave. These are R wave that peaks on a heavy black line, our start line. Then next line is 300, then 150, then 100. Please memorize this in this way: 300, 150, 100. Then number the next 3 lines after 300, 150, 100 as 75, 60, 50. Start M and the R. Next 300, 150, 100, 75, 60, 50. Why the next array falls determines the rate. It is that simple. That is, we have to start here 300, 150, 100, then R wave, then 75. Then the next R wave falls, so the rate is 75 to 100. Practice this ECG. This is an ECG tracing from a resting patient whose heart rate is lower than the usual rate, 1 would see with a sinus rhythm. Let's examine the rate. First of all, we have to find R wave on the black line. Then 300, 150, 100, 75 and 60. So the heart rate is 60. Again 300, 150, 100, 75, 60. The distance between the heavy plug lines represent 1 by 300 minute. So the two 1 by 300 minute units equal 2 by 300 minute equal 1 by 150 minute or 151 minute rate. This 3 1 by 300 units equal 3 300 equal 1 by 100 minutes. Bradycardia slow rates. For any slow rhythms, there is an easy method for quickly determining the rate. On the top margin of the ECG strip, there is small marks that identify the 3 seconds intervals. These are 3 seconds mark. Taking 2 of the 3 second intervals, 2. We have 6 second strip. So if there are 4 cycles times 6 second strip, the rate is 40. You can just place a 0 on the right of the number, cycles plus 6 second strip, and rate. The general average rates of irregular rhythms are usually determined using this method. Thank you. Next will be the rhythm.